All right, so we're going to find the bimodal solid rotating about a given curve or a given axis is probably a better word. So we said y equals 3. All right, and again, this is find the volume of solid. There are two distinct ways of doing this. All right, we can do this using ax dx, because y equals 3 is horizontal. All right, or we might be able to do cylindrical shells, but it'd be really ugly for cylindrical shells. But we'll do both methods here. I'll start by drawing the curve. So it's y x square root of square root of x minus 1, so it's shifted 1 to the right. So the curve itself looks like this, 2, 3, 4, 5. There's this curve, so it's this area right here. Trapped between x equals 5, y equals 0, and this curve. And you want that shifted or rotated about y equals 3, which is, and this is not the scale. It doesn't have to be the scale. But y equals 3 is above the curve. The points here is 1, 0, that's bottom. This point here at 5 is 5, 2. So I would think...
Mr. Smith, would you please report to Jolene Albertro? Mr. Smith, would you please report to Jolene Albertro? Thank you.
I think this is the easiest way to do this problem this time. We'll do it with the cylindrical shell method too. Here we'll set it up. We won't do that method all the way out. So you got to look at this and say, all right, I have to rotate this red area above the blue line. I have an RI and I have an RO. This shape has to be a washer. So if I do that, and again, if I'm going to do it on the x-axis, my limits are going to go from 1 to 5. All right, and my a of x this time is pi RO squared minus pi RI squared dx. But you can't just use the function now. You're going to have to define the RO and RI. I think the RO is awfully easy. What's the RO every time? Put it on 3. It's always to the x-axis. This distance right here, I'll put a green line in here and I'll move it. If I move it, it's always 3, all the way through there. So we don't have to worry about that. All right? It is always 3. Now the RI changes. I want the RI to be right here. Well, I can't measure that. What I can measure here is the y distance to the function, right? So RI this time is 3 minus y, or in this case, 3 minus the root of x minus 1. You guys agree? All right. So let's set this up. And I get the integral from, I'm going to bring the pi out, factor pi out. 1 to 5, 3 squared minus 3 minus the root of x minus 1 quantity squared dx. Well, this would be the point where I might grab my TI calculator and integrate this, because this is going to get ugly. In fact, I don't think we can integrate this. I don't think the middle term is something we can hand integrate. All right? Because you're going to get -6 square root of x minus 1. Well, to get that, yeah, it's going to, when you do the binomial, this is ugly.
You did that on right?
Well, yeah, so you get, I agree, you get 9, but I'm talking the middle term of binomial.
Oh, yeah, that's bad.
It's bad. You agree it's this? I mean, if I square this out, 9 minus 9 goes away. I get 6 times the square root of x minus 1. Well, I suppose, I guess it is doable, actually, isn't it?
I can
Here it is. Here it is. That is set up. If I want to find now the volume, I have to do the integration of this. I'm more concerned that we see that this is the situation we have, all right? That we can set this up. From here, we could do the integral and get it done.
Help with you.
You want me to
You
do
don't,
it?
you don't have to do it, just help with you.
Well, all right, think about this right here. How would I do that part? Do you agree? I'll do it in blue.
Would you use this tool?
You can think of it that way. Exactly. Think of it's this. Because the power inside of this radical is 1, you can integrate. Just add 1 to half, and it all works out. All right? You can get it will work. I mean, I can do the integral. I really don't want to spend time with it. So, but
Yeah,
if
you
you
don't
get it,
have to.
no, but I can at least write it. I'm not gonna. Let's not substitute in. It would be 3/2 over 3/2 plus x squared over 2 minus x from 1 to 5. And if you substitute 5 and 1, it'll work. Okay? That said, there is a method to do it. Could we do this with cylindrical shells? You just did. And Matt, do you think it's easier with cylindrical shells or harder?
I'd say harder.
You'd say harder.
A little bit.
Alrighty, so,
Still writing. Okay. So I have. So if I group all this and get it all kind of out of the way, the question is, can I do the same thing with this with cylindrical shells? All right. Now cylindrical shells this time, all right, you have to picture this a different way. We would actually have to do, and this is where students a lot of times get confused again. If I'm going to go around y minus 3, I have to go across the y-axis because my slivers, I draw that shape there and I'm going about here. The circumference, the sliver in the cylindrical shell, right, the thickness here, it is a y distance away and it's dy thick, right, because you're doing circumferences. So this will become, again, the idea of setting it up. And we would go, you know, from 0 to 2, right? The integral is the y. So you can pull 2 pi out, 0 to 2, and now it's not y. This distance. It is not y high. It's this y, which is a different distance, right? Shouldn't even call it y, because our actual y distance at any given time is right there. Distance from y equals 3 to this y sliver of dy is what? 3 minus y. So this is actually, because again, this is a circumference. That y is 3 minus y. Now I need f of y. Well, come back up here, right? You've got to solve this equation for x. Do we agree? You know, I can do this pretty fast. Solve for that. Okay, so that is that this distance here? No, that is this distance here. Oh my gosh, right? It's the dotted line. Think about what that measures. That comes from the y-axis to this point. But what do I need? I need this solid red line right here. So I need to do 5 minus that junk. So I get 5 minus y squared plus 1. And I positively do not want to do that one either. But that is set up. And I've just set up both integrals to do this. Your TI calculator, listen, the way I would do this problem is I would simply plug this integral into my TI and say solve by TI on my homework, my AP test, my test for me, whatever. Solve by TI-84. Have whatever number gets pumped out of here times 2 pi as a decimal. All right?